So let me take you back 10 years, and Steve Jobs kicked off the smartphone revolution when he introduced the iPhone. And on the iPhone, there was kind of a mobile browser, but it was a pretty poor experience of going online. So a year later, he kicked off the App Store, and you've got the native apps. And this is a really good way of getting online and interacting with online content. And I'm sure you've all used that, loads of apps over the last 10 years. Maybe the Gmail app for sending emails. Maybe use Twitter for sending tweets. Snapchat for sending delightful pictures of yourself. And then there's plenty of you, I'm sure, who waited many weeks and months playing the king of apps, Flappy Birds. But since 2008, the mobile web has increased dramatically. When you're out and about, I'm sure that many of you are looking at URLs in your Chrome browser. But native apps have a huge benefit in loads of areas. So first of all, we're going to talk about performance. So native apps are fast and quick to respond. When you first get out your mobile phone, you've got a really nice icon that you can click on. Straight away, as soon as you click on that, you get a really nice scaffolded app that comes up. Let's say you've gone to Facebook, it's kind of a nice blue look, and you've got a Facebook icon. You've probably got a load of cached content. So when I get my Twitter app up, I've got a load of tweets there, so I see those straight away. There's no going into Chrome and trying to find a URL and trying to load up a page. They also have a smooth, consistent, self-contained UI. So the native app looks really good on your phone. You kind of enjoy using it. It kind of feels you know exactly where you are. And the killer piece for a native app is it works consistently well offline. So whether you should be checking your emails on the tube, that's another matter. But you can check your emails on the tube. They've been synced during the day. You can then sit back and reply to one of those emails. When you come above ground, off it goes, and all works well. If you try and do that with a normal web app, it doesn't work. But why aren't native apps everywhere? Why aren't we using native apps for everything we do if we've got all these benefits? Anyone developing native apps here? We've got one person here. How is it?
This is true.
Cool. Great, okay. So I'm not a native app developer. I've just heard a few stories that it can be painful. So there's different languages between Android and iOS. So you've got Java, maybe you're funky and hipster and you use Kotlin. Otherwise you're using Swift. You can use React Native, but you still have to change the way you develop a whole load of things. So there's a different way of doing CSS. Even within React Native, you have to do different stuff depending on the platform you're on. And even then, you kind of have to develop differently for the web. So you're already developing for 3 different platforms. It's expensive to develop. Expense is very subjective. So if your business depends on an app, you really need to develop that app. So you need to run 3 teams. And that's really part of how your business works. But if you're a small startup or you're trying to do an app on the side of a bigger business, then this can be incredibly expensive to have sort of 3 different platforms to support. So at Moo last year, we introduced an iPhone app called Monogram, and it was completely different from our main business, and we had a whole separate team to do that. It was kind of an experiment into how the social world worked and whether we could make a social app work. It was just incredibly expensive to keep a separate team just purely focused on what was an experiment. And I'm sure there's lots of startups and companies out there which have really struggled to support native apps in all the different platforms. And then there's also the application process. So I think this has got a lot better. Maybe 10 years ago it was pretty painful, but there's still a process to get into the App Store. There's a different one to get into Android. And then even the release process, we've just seen if you want to release stuff on the web, it's out there, it goes to your customers straight away. With a native app, you have to rely on your customers that they're constantly updating their phones. I don't know that much about native app development. There's a really good video from Kate Huston at the lead dev. So if you're interested, these slides will go around. You can go and have a look at that. But anyway, this is about progressive web apps. So obviously, progressive web apps to the rescue. And this is JavaScript Roundabout, right? So one of the best things about progressive web apps is it uses web standard technology. It uses JavaScript. Yay. Thank God I talked about JavaScript at a JavaScript meetup. It's got most of the benefits of native apps, including performance. Again, quite about the performance stuff in there. Write once, work everywhere. So everyone's hopefully building responsive websites. Fingers crossed. There's little bits of Moo that aren't, but mostly we're responsive. But you just build it once, and hopefully it should work everywhere. You have one team, maybe you need a few tweaks depending on for mobile, and yeah, you still have to test it on IE8, sort of IE8 and IE9, but let's ignore that for a moment. But what does progressive mean? So everyone in the JavaScript world's heard of progressive enhancement, hopefully from back in the days. So in the old days, we used to have static HTML pages, and then JavaScript came around, and we wanted to enhance our pages. So the sort of design pattern there was the JavaScript can make the app faster and feel better, but if you didn't run JavaScript, it would still work really well. And it's the kind of the same thing with progressive enhancement. It's a whole bunch of features that you can add to your app. There's 11 that Google list, and each of these should improve the experience for the customer. But if their platform doesn't have one of those features, it shouldn't break your app. So again, this progressive web app is a case of extra technologies they can add to the performance of your app. With more of these features, you see the benefits across desktop and web. I kind of always keep comparing against native apps here, but a lot of these performances are also on the website. So if you have a website and you don't really care so much about your mobile customers, a lot of these technologies can really improve the performance of your websites. And here's the link. So if you go there, there's a whole bunch of 11 really cool things that Google lists. I'm going to talk about a couple of those in a little example I've got. But you can go there. Some of them are like, you need HTTPS on your site. Hopefully, most important websites have got HTTPS. There's a bunch of stuff ranging from that through to your website should work offline. Cool. So I'm going to give you an example. That's kind of enough like top level talking. We might even show you some JavaScript as well. And I kind of always wanted to build a native app, but it felt like a huge amount of effort to learn the process and learn the different languages and learn the structure and get the app out into the App Store. But I have built some side projects, some single page apps. And the other week I was like, well, I've kind of always wanted to try and get one of these to maybe be an app. How hard can it be? So I read a few blogs about progressive web apps, and there's some terms there that I didn't understand, but you sort of sit there for a day and bang your head against the wall, and eventually these things kind of play out. And it was a lot of the same technologies I use in my day-to-day work, so it felt quite comfortable. Now, the type of sort of side project that works really well is a single page app, because a bit like a native app, you've got kind of a structure on your page, and you're updating some of the content through some API calls off in the background. This is my blog. I apologize for the design. I'm not an amazing designer, but there's lots of white space and some green stuff around. And just a bit about that technology. I know everyone's using React, but this is handlebars and jQuery, a bit old school. It's isomorphic, which means that you get the initial render of the page from the server is fully rendered. So we've got handlebars rendered on the server side. And yeah, the single page app. So we're going to talk a little bit more about some of the key features of a progressive web app and why just having a few endpoints really helps sort of do the testing for that. So there's 3 steps. Let's see if there's any JavaScript in the first step. JSON, is JSON JavaScript? Let's say yes. First of all, the manifest.json. This is just some config. If you can just about read there, it's basically got a name for my app. It's got a link to an icon that I want to appear on the home page of the phone. And it's got some theme colors. So this is back to that UI that you want a kind of consistent theme color to your app when it opens up on your phone. Cool, that was step 1. Step 2, no JavaScript here. But we want to link to the manifest.json in the head of your HTML. So it's just a link with a manifest tag there. The other part that you put in the head of the HTML is a theme color. So you saw my app, it was kind of white with a bunch of green there. This is, for anyone who knows the hex, that's kind of green. And this is a screenshot from my app on my phone. And you can see that that top bar is already that green color, which fits in with the theme of my app. Cool, step 3. Service worker. Ooh. I'd heard loads about service workers and kind of got it in my head that they were really complicated, and it's a load of JavaScript with a bunch of promises. So if you know your promises, service workers are kind of not too bad. It's JavaScript, yay, JavaScript roundabout, yay. Proxy server, God. So the service worker sits between the browser and the network. It's a proxy server, and there's a bunch of JavaScript logic, and you can manage your cache programmatically. Basically, you get access to any of the requests that come in from the front end, and you can do what you want with it. We're going to go through a little example of just a very simple one that I did for my app. Matt already talked a little bit about Varnish and setting headers and stuff. Some of that sort of VCL language and the headers can be a little obtuse, and this is a more programmatic way of managing that cache in the browser. CloudFront are actually going to allows service workers to sit on the edge. So if anyone's dealt with VCL, varnish config language, this is going to be a way of using JavaScript in your CDN. Cool. It's progressive web apps. First of all, we want to check that our app or that our client can use service workers. So this is just in my main.js, which is my main JavaScript file for my app. And just check that I can use service workers, and then we'll register my service worker. And I've got this service worker file, which is sat in the root of my directory. Second bit, we've got a cache name, and then a bunch of files that I want to cache. So the service worker is this proxy server, and all I want to do is have a whole list of files and assets that I want to cache and sit there. The service worker will store that, and it means that when my app's offline, I can hopefully use this cache to serve that content to my customers. As you can see, my app's not super complicated. There's an API which I can get all my posts from. It's worth noting that you don't have to be limited to routes that are in your domain. So here I'm getting some Google API stuff, some fonts. I've got a couple other JavaScript files there. So that's the first step. Second step, you get my service worker. There's an event lister for it installing, and I want to do some logic when it starts installing. And this is the key line, cache.add all the files to cache. It's that full list of files that I had before. I try and add them to my cache. My service worker goes through that whole loop, goes off to the network, fetches content for every single one of those routes, and that backs into my cache. For promises, so you've got wait until, so this is kind of promise, is wait until all those files are added into the cache. When that's finished, it says my service worker is installed, ready to go. After it's installed, the next thing I want to do is if someone in the app requests anything, I want to interrogate that request, and then I can do what I want with the cache. This is a very, very simple example that on any fetch request, I go through my caches.match, and I check to see if the request that's come from my server is in my cache. If I do have a response, I'm just going to send that straight back. So if we're talking about performance, if there is something in my cache there, I'm going to send that straight back to the client, and my page is going to render immediately. Otherwise, I'm going to send off the request out to the network, and hopefully it's going to come back to me. This is kind of one caching strategy, just a couple of lists of other things you can do. You could return the cache immediately and refresh that cache in the background. Maybe you call off to the network first, but if your network's really slow, let's say your user is on a 3G network, maybe you call off, and if nothing's come back within 1 or 2 seconds, you can return whatever's in the cache. You can do a whole load of other logic in here. So if you know that your customer is at a certain point in the journey and they will need some other assets further on, you can call off in the service worker and go and get some images. Let's say they're looking through an album of photos. You can go and prefetch some of the photos in the next page. Let's say you've got some pagination, you can go and get some content for the next step. You can even sort of build up the DOM or build up some HTML in the service worker so that the next step in the app is really quick for the customer. Cool, almost native. I'm just going to show you some screenshots here. So this is what happens when those 3 changes. So I added the manifest.json, I added the little content in the top of the page, and I've added the service worker. And this is what you get. So I open my app up in my Chrome browser, and a little button pops up at the bottom. So it's a really simple way of allowing your app to get added to the home screen of your phone. So instead of going to an app, into the App Store and installing it, as soon as you open up my web page, you get this little button. I built an icon. You could probably build a better icon, but you can see there on the right, it's the blog, nice sort of green thing. There's a couple of other icons there. There's a Hacker News one there, which is a progressive web app. Someone's built a Hacker News with Vue.js. The rest of those are all native apps. As soon as you click on the blog, you get this really nice green screen, again with my terrible icon in the middle, and the name of my blog there. And once that's opened up, you get the whole page here. The great thing about this is you don't get the URL bar at the top. So you can see that this screen on the right looks and feels just like you'd installed a native app. All we've done is written maybe 30 lines of JavaScript. We had maybe 20 lines of a JSON. We had a couple of things in the HTML at the head. You didn't have to go through any app store or any other kind of process to get this onto someone's phone. and it works offline, and it's fast with a slow network. I'm going to carry on with the slides. We can double check that it works offline. Live demos are always terrible. But it does, when I'm on my phone, I can go read my whole blog. I wrote it, so hopefully I should remember what it is. My mum gets to read it when she's at home and she doesn't have internet connection, so she's really happy. Cool. I'm just going to show you a few tools that you can use to help debug the app. I think I get really stuck in my development that I use the same things in the Google Chrome console. It's really cool to know that there's other things that are there. I think there's loads of things that I'm way off learning about. On the application side, there's a whole chunk of stuff on the service workers, and you can see a lot of the sort of process and flow of your service worker and exactly what's stored in the cache. If you haven't discovered it yet, in Chrome there's also an audit tab. It's a bit like web page test, so it does a whole bunch of audits for your app. So you can also look at performance here. But there's 4 scores, and one of them is a progressive web app score. I'm doing a talk about it, so thank God I got 100 out of 100. There's 11 past audits here. You can click on them. So if you've got an app, you'll probably pass a few of them. Like if you have HTTPS, you've already scored 1 point out of 11. There's a whole bunch of other things there with little tips and links on how to get your app to be progressive. I imagine Google, they're starting to use more and more that people's websites work well on mobile for their rankings. I imagine at some stage in the future, something like the score on the progressive web app will be part of their rankings. Gotchas, there's always gotchas. What are the 2 hardest things in computer science? So cache invalidation, naming things, and off by 1 errors. Caching is hard. You get it wrong all the time. We get it wrong at Moo a lot. There's been outages in the 2 years that I've been there because we screw up headers and we mess things up. Caching is hard. Don't cache customer user data if it shouldn't be cached. You really want to give someone else's private data to someone else. That's my number 1 tip for today. So if you don't remember anything else, don't cache people's data when you shouldn't. In Chrome, sometimes you have 2 tabs open and the service worker is registered with 1, and you try and refresh and it doesn't refresh the service worker. And then you try and change some other stuff and you close all your tabs and you close Chrome and you open up again, it's still not working, and then you realize you've been refreshing the live site, not your dev version. But that's just JavaScript debugging for you. But there are some little gotchas with service workers that you kind of need to get used to when you're trying to work with it. Finally, your app works offline always, even on localhost. So I've been developing, I shut my app down, I came in a couple of days later, I opened up Python Simple Server, it was running on the same host. I went to my browser and it refreshed the app that I've been working on 3 days ago because it's been stored for offline use. So this new thing that I've been working on was sat behind my offline app. So you just have to make sure you change your port number and remember that this thing's stored in your cache somewhere, or delete it and get rid of it. Cool, so conclusion, progressive web apps, awesome. Web standard technologies that can be used to improve the performance. Yeah, we've got performance in again. And feel of your website. Build once, work everywhere. Yeah, it's JavaScript, yay. Cool, thank you very much.